Hello friends, we're back today to talk about two lessons. The first one is going to be reducing the impact of natural hazards. So we know that there are natural hazards out there. We specifically talked about tsunamis, volcanoes, and earthquakes, and this lesson is going to revolve around reducing some of the impacts of natural hazards during an earthquake. This first sentence is one of the most important things we talk about in the whole entire unit. We've said it before, and we'll say it again, and this won't be the last time you hear it, but natural hazards cannot be eliminated, but people can take steps to reduce their impact. So again, let's go over that. Natural hazards cannot be eliminated. We can't make volcanoes, earthquakes, and tsunamis go away, and we cannot stop them from happening. But as humans, we can take steps to reduce their impact, which means making it safer for people to be around. As we read in our last lesson, tsunami detection exists to help lessen the impact on humans by allowing them to know, not a whole lot long in advance, but at least a little bit in advance of a tsunami hitting the shore so that they have time to get to either higher ground or go further away from the coast to try to stay safe. In earthquakes, it says, for example, engineers can design buildings and bridges to withstand the violent shaking of earthquakes. This reduces damage and saves lives. So you might be thinking to yourself, how can they make buildings and bridges that can withstand earthquakes and not collapse? Well, let's look into that a little bit. So this caption right here says, the San Francisco-Oakland Bay Bridge in California is designed to withstand a major earthquake. Now you may or may not know this, but California often gets earthquakes of all different magnitudes, and magnitude means how severe the earthquake is or how strong it is. The reason California gets so many earthquakes is because we've talked about faults before, right? You know what a fault is. A fault is a break in the Earth's surface where slabs of rock either push against each other or pull away from each other. And there is a fault in California called the San Andreas Fault. Now, because this fault is in California, that means that there are lots of opportunities for those slabs of rock to push against each other or break apart from each other, causing earthquakes. So that's why California is one of the places on the earth that does have a lot of earthquakes. So this bridge right here is designed to withstand a major earthquake. Okay, so this is the bridge we're talking about right here. Okay, let's kind of take a look a little bit more at that and kind of see what they mean by being able to withstand an earthquake. Okay, so right here, this is called a suspension bridge. And just like you might think from the title, suspension means part of it is suspended. And I don't mean suspended like you've done something wrong from school. So let's kind of look at that. The suspension bridge contains a motion detection system which warns drivers of earthquake danger. So there is actually a warning on the bridge that if drivers were on the bridge when an earthquake began, they would be warned of that. It would maybe warn them before they got on the bridge, because obviously bridges can be a very dangerous place during the earthquakes, okay? So these warning systems exist to either let drivers know when they're on the bridge that there's an earthquake, or even before they get on, maybe they can stop before they continue driving onto the bridge, okay? Let's look at these two plus signs and kind of see what they're talking about. The main tower, which is this part right here, and you know there are several towers in bridges. The main tower has four pieces that move separately. They are connected by links that can bend or break, absorbing the shock waves. Okay, so what that means is this tower actually has four pieces to it. This is what would look like would happen if we kind of sliced it apart, but you can kind of see the four pieces right here as we kind of move around the tower. These four pieces are connected together by links. These links are able to bend and they're able to break. Now, why might that be a good thing? Well, as the bridge is subjected to movement from an earthquake, the fact that something can bend or break separately can keep the whole tower intact. So let's just say in the earthquake, this part right here breaks apart. The bridge will still be able to withstand the earthquake because the links here, here, and here would still be connected. Okay? And let's just say these were able to bend a little bit. Again, if it bends but doesn't break, you've seen that happen in other things before, it would keep it intact to keep this whole tower from collapsing and taking the rest of the bridge with it. This right here shows us the cables. So these things over here are called cables. Cables support the weight of the bridge. A single cable connects to each of the 4 parts of the tower. Okay, so these cables are connecting to each of the 4 parts, which means, again, if one part were to break off, it would not collapse the whole bridge because those cables are connected to each of the 4 parts. So again, let's say this whole section right here, say this link breaks and this link breaks and this part of the tower falls off. The bridge will still continue to stand because of the other 3 that are still in place, and the fact that the cables will connect to each of these make it so that they can continue to support the bridge, and it will not collapse and it will not injure the people that are on the bridge. Okay, so that's a pretty cool thing if you ask me. And obviously bridges like this exist in California because they are so susceptible to earthquakes, which means they get a lot of them. I wonder if we have bridges like this where we live. And the answer is no. Okay, there are certain types of suspension bridges that exist, but that doesn't mean they're the same thing as these bridges. And quite often you will not see bridges like this in our area, and that's because we just don't really get earthquakes in our area. Okay, not saying it never happens, but we don't really get them, and if we ever have, they've been pretty mild. Okay, not enough to cause any damage like destroying a bridge. So it makes you wonder, why don't we all have this? Okay, so just because we're in New Jersey where we don't get a lot of earthquakes, I wonder why we don't have bridges that look like this. And the answer is because bridges like this cost a lot of money. These bridges are more expensive than normal bridges like we see when we travel to Philadelphia or New York. So the reason why we don't have that is because if they put bridges like this wherever there were bridges, it would cost a whole lot of money. And we simply just don't have enough money to construct those bridges, so instead of doing them everywhere, engineers and planners put them in cities that are most likely to have earthquakes, that are most likely to have bridges damaged in an earthquake. And we're going to move right into our other topic for today, which is called early warning systems. Again, you've already read about tsunami detection systems, which are a type of an early warning system specifically for tsunamis. But what about earthquakes and volcanoes? Well, guess what? We have early warning systems for those as well. If people know that a natural hazard is likely to occur, they can take steps to reduce its impact. But how can people know when they're in danger? Scientists use many methods to help predict when natural hazards are likely to happen. All right, so we're going to talk about a couple vocab words now. You have the word seismometers. Seismometers measure earthquake activity. Okay, so just like in math we use the word meter and we use meters to measure things, a seismometer measures earthquake activity. It actually gets, it's a device that actually measures the amount of activity going on in the earth to determine whether or not it's a normal movement, or if it gets too high, that movement can be indicative of an earthquake. It means an earthquake might be happening. An increase in small earthquakes can mean a larger earthquake is about to happen, or a volcano is becoming more active. So usually when there's a big earthquake, there have been smaller earthquakes leading up to it. So there might be like a small one, and then like a little bit bigger one, and a little bit bigger, and a medium one, and a little bit bigger, and a little bit bigger, until there's a really big earthquake. So if scientists are noticing that the earthquakes are getting a little bit larger each time, it could be an indication that a larger earthquake is on its way. And you might be wondering about volcanoes, but guess what? One of the ways that we can predict if a volcano is about to erupt is based on the movement of the earth around the volcano, just like with an earthquake. It won't be as much movement, but there is some indication if there's some earth movement. If a seismometer picks up some movement around a volcano, it could be an indication that the volcano may erupt soon. If a volcanic eruption is predicted, people can evacuate or move to safer areas. Okay, so remember when we talked about volcanoes, we said the very best way to avoid being injured or hurt by a volcano is to just not live near a volcano. But for some people, that's unavoidable. So if you have to live near a volcano, you should, when a volcanic eruption is predicted, you should evacuate, which means move to a safer area. Okay, that might mean move to a city further away from the volcano, or, just drive further away. But whatever it is, it means move yourself away from that unsafe area. Governments can prepare emergency supplies such as food and water. Emergency workers can be ready to help with injuries. All of these steps reduce the impact and help save lives. So because people can know that earthquakes or volcanoes might happen because of these seismometers, they can prepare things like emergency workers or food and water to help if you are displaced from your home in any way or if you are hurt. Scientists use several devices and methods to constantly collect information about a volcano's activity. Radio transmissions allow the data to be sent instantly to a monitoring system. Okay, so similar to a tsunami detection, if scientists' devices are showing that there's some movement going on around a volcano, they can transmit through radio, and we know how that works because we had a lesson about that a while ago. The data can be sent to a monitoring system and then can be distributed to people and let them know that there might be an earthquake on its way or a volcano eruption. Scientists can tell what's happening with a volcano almost as soon as it happens. They can also use information to predict what is likely to happen next. Okay. In addition to tracking seismic activity, anything with the word seismo in it or seisma in it means it's related to earthquakes. And you might say, what does an earthquake have to do with a volcano? But they're saying here that movement of the earth around the volcano could be an indication the volcano is going to erupt. A change in the amount of carbon dioxide and other gases given off by the volcano can signal a coming eruption. So can temperature changes in the rocks at the surface or rocks underground. Scientists monitor water levels and look for changes in chemistry and water near volcanoes too. So besides possible earth movement, some other ways to know if a volcano is going to erupt is by measuring the air, because if there's a lot of carbon dioxide or other gases that are coming from the volcano, that can be an indication that it's about to erupt. If the temperature in the land or the rocks around the volcano changes, if the temperature starts to increase, that can indicate that the volcano is about to erupt. And water levels nearby, if we look at that and the chemistry in the water, which means what is being present in the water, if there are any chemicals in the water, can indicate that the volcano may erupt as well. Okay, lots to read on this page. Let's check this out. Scientists continually monitor the gases coming out of active volcanoes. Okay, and that would mean volcanoes that could still erupt, because there are inactive volcanoes as well, volcanoes that will no longer erupt. But near any active volcano, scientists are measuring so that they can give warning if it is about to erupt. Okay, here, this is the seismometer, okay, that detects earthquake waves. An increase in earthquakes near a volcano can be a sign of increasing volcanic activity. Okay, so this is the actual seismometer that would measure the movement of the ground to see if there's an earthquake coming. Ground motions sensed by seismometers are converted into electronic signals. The signals are transmitted by radio and recorded on seismographs. Okay, so we know all about radio signals again. We know that they can transmit information. This, however, is called a seismograph. And think about in math again. When you graph something, you're usually drawing a picture to represent how much of something that there is. So this and this are the same. This measures the activity, and this records the activity. This records whatever this feels. Okay, so seismograph measures it. Seismometer measures it. Seismograph records it. So just like we would do in math. Okay. Last picture we have for you here. Swelling, sinking, or cracking of the ground near a volcano can mean magma is moving beneath the surface. Tilt meters detect any movement of magma close to the surface. So there is yet another way to detect if a volcano is going to erupt, and that's called a tilt meter. And that is a device that is measuring the movement of magma that is close to the surface, not deep underground, but closer to the surface, closer to becoming lava when it comes out of the volcano. Okay? I know that was a whole lot to think about today, but let's focus on the important points. Suspension bridges can help reduce the impact of earthquakes and keep bridges from collapsing. And we're also going to talk later about how they do the same thing for buildings. Seismographs and seismometers and tilt meters are some of the devices that scientists use to monitor not only earthquake activity, but volcanic activity as well, so that they are able to predict when an earthquake might come or when a volcano might erupt. Besides measuring the ground around a volcano, scientists also measure the gases that come out of the volcano, as well as the temperature in the ground around the volcano. Okay, like I said, I know that's a whole lot, but hopefully you guys enjoyed that. Good luck on your fill in the blanks and time to climb, and I'll see you again for the next lesson.